of the FDP. For today's first session, we have Dr. S. Raghunath sir with us. So he'll be talking on masonry structures and approach towards sustainability. We welcome you, sir, on behalf of the Department of Civil Engineering, DSATM. Now I request our HOD sir, Vishwanath sir, to introduce the speaker to the participants. Over to you, sir. Vishwanath sir.
Yes, madam.
Yes.
Very good morning to all the participants and our respected yes, Raghunath sir. Sir, very good morning, sir. I'm Vishwanath here.
Good morning, Professor Vishwanath. Yeah, nice speaking to you.
Thank you, sir. Thank you. After a long time, sir.
Yes, it's been around.
Yes, sir. Yes, participants. Raghunath sir, of course, he completed his undergraduate and postgraduate in construction technology from USCE, Bangalore, and PhD from Structural Engineering Division of Indian Institute of Science, Bangalore, under the mentorship of K.S. Jagdish, whom all of us in India know as the person for alternate building materials, low-cost construction, sustainable constructions. So under K.S. Jagdish, sir has done his PhD. And sir, research interest includes structural masonry, experimental dynamics, earthquake resistant buildings, alternative building materials, as we said earlier, energy and buildings, restoration and structural strengthening of heritage buildings is a special forte. Sir has, of course, he has been in the teaching and the research for the last 33 to 35 years. And he has guided more than 60 PG dissertation works and 8 PhD under his mentorship. He has also carried out many R&D projects approved by sanctioned by DST, Government of India, and VGST, Government of Karnataka. Sir is a structural consultant for many government and private agencies, especially in the area of structural masonry and the restoration of heritage buildings. Sir is actively involved in Nivasa, an architectural NGO working to enable human and dignified housing conditions for urban and rural poor through designing. He'll be contributing through the designs. So that is his human face. And we have all of us in Bangalore or in Karnataka now who are in a professional course have grown seeing Raghunath sir and his teachings and his, though he is not directly teacher to us, we always consider him as our teacher because, as we said, we are grown looking at him, learning from his teachings and his societal oriented service. Sir, with a very brief, of course, we have very large explanation for Raghunath sir's biodata, but sir requested us to shorten it. And this is in brief about Raghunath sir. Sir, we are really glad to have you, and I welcome you once again for the session. So kindly take over, sir. It's your thing. We are eagerly waiting to hear from you, sir.
Thank you, Dr. Vishwanath. It's really nice to listen to you after a long time.
Thank you. Thank you so much.
I always was eager to catch up with you in some context or the other.
Yes, sir.
Maybe I'll get some opportunity to discuss with you in person.
Definitely.
Thank you. At the outset, of course, I would like to thank you personally. And then Dr. Subha Lakshmi. I haven't had an opportunity to see her, okay, though she has been contacting me over the phone. It's nice talking to Subha Lakshmi. And she was the one who requested me to share my thoughts on structural masonry. Thank you, ma'am. Okay, so
Okay, sir.
can I start my presentation?
Yes, sir. Yes, sir.
Yeah, I have given you the presenter rights. I think you can share the screen and so you can start.
Yeah, I will do that. Okay, I'll just take a couple of minutes and then I presume my screen is visible.
Yes, sir. It is visible and you are audible as well, sir.
Oh, thank you. Okay, thank you very much. Yeah. Okay. Again, thanking the organizers for inviting me to discuss about structural masonry. I'd also take this opportunity to sort of compliment the organizers for carrying out this workshop for the faculty members. Sustainable design with pre-engineered design and approach towards eco-friendly design. It's a relevant topic in the current context. I think it's a good program for faculty members to be involved with. And I also saw that quite a good number of eminent speakers are there. Of course, my professor, my teacher, Professor Jagdish was there yesterday. So he is the best person to be introducing this course to any participant. I'm going to discuss about sustainable approach, or probably I'm going to introduce masonry. Just a minute, there's some problem with it. Yeah, I'm going to discuss something about masonry by dividing my lecture into sort of 5 parts. Initially, I'm going to discuss something about sustainability, my personal thoughts on sustainability, and then I'm going to introduce masonry from that lens. Okay, how masonry can be considered as sustainable. And then I'm going to share the bulk of my contents through introduction to structural masonry and give reference to quite a few examples of historic masonry structures. And then I'm going to move towards the end of my lecture by arguing that masonry can be considered as a sustainable construction in many aspects from many contexts and things like that. And then end my session with a few concluding remarks. Of course, sustainability or sustainable development is something which different people have got different idea and opinion about. Okay, it has got a lot of context and then a lot of way in which one has to interpret it. For example, these days you have this concept of sustainable development goals. The United Nations have come out with SDGs. Okay, that looks at sustainable growth in a very comprehensive manner. And different people can talk about sustainability by giving different weightages to the 3 aspects: the economics, and then the social aspects, and the environmental aspects. By giving a different weightage to each of them, they can argue that things, certain processes and certain technologies and then materials are sustainable. Okay, that's also okay in many ways. And you can also talk about sustainability in terms of a time frame. Okay, in a context, okay, in a situation. So what is sustainable in one context may not be sustainable in the other context. Okay, what is sustainable in a short term may not be sustainable over a long term. Things like that. There have been people who are talking about short term sustainability and long term sustainability, though it appears to be some kind of an oxymoron. By and large, all of us understand sustainability with one clear-cut definition. Okay, with respect to the definition of sustainable society, it is considered as the one in which, okay, the society grows, okay, or manages its economic growth in such a manner, okay, that there is no irreparable damage to its environment. Okay, this is something which most of us would like to accept. Okay, I think it's personally I also accept this definition. It satisfies the needs of the people without jeopardizing the prospects of the next generation. Okay, so we need to protect our environment and hand it over as a good legacy to the next generation. Okay, that's the meaning of sustainable society. Although the concept of sustainability is being talked about in the current context more and more, the concept of economy of permanence, the book written by Joseph Kumarappa, okay, he talks about sustainable development through his book, a very neatly written book, very easily comprehensible by even non-economists. Okay, he's been talking about the economy of permanence. He talks about equitable development. So that is also a very interesting book one can refer to. It is available on the open source. And then personally, my own understanding of sustainable development and sustainable technologies and things like that is because of two important things. Okay, one is of course my interaction with my teacher, Professor K.H. Jagdish, and the interaction with my colleagues and then friends, and then quite a few books. Okay. Two of them I have just mentioned in this slide. The Small is Beautiful is a book written by Schumacher. Okay, it talks about economics as if people matter. And then his contemporary and junior George McRobbie also wrote a book called "As Small is Possible." Okay, these are all some of the important background in which I have understood and then sustainability and tried to contribute to this lecture in this, or to this aspect, or to this field of engineering. The two key concepts of sustainability are the concepts of the needs. Okay, in particular, the essential needs. Okay, you can talk about vital, essential, and desirable. Okay, so the essential needs to which overriding priority should be given. Okay, so if you are able to balance the needs, I think one can approach sustainability in an easy manner. And then of course, the needs are also limited by the availability. Okay, there is a limitation imposed by the state of technology, the social organization on the environment's ability to meet the present and the future. Okay, so the technology should evolve in such a manner that the needs are catered to, okay, without jeopardizing the environmental and other aspects. Most of us understand the concept of sustainability through this very popular Venn diagram. Okay, something is said to be sustainable, either a technology or a product or a process, okay, or a material is said to be sustainable, okay, if it is economically viable and environmentally friendly and socially acceptable. If all the three of them are satisfied simultaneously, then it is said to be a sustainable technology or a process or a material or a product. On the other hand, if it satisfies the social requirement and economic viability, then it is called as an equitable solution. If it satisfies environmentally, ecologically, and then from the point of view of environmental degradation and things like that, and if it is economically viable, then it is simply called as a viable solution. If it is socially acceptable and environmentally friendly but not economical, okay, then it is called as a bearable solution. Very quickly, one can understand these definitions through some examples. Okay, I will leave it to the participants to look at the things which are given on the right hand side of this slide. For instance, plastic bags. Okay, they are equitable solutions. It may not be environmentally friendly, and we don't have a technology to recycle and reprocess it to the correct extent. Okay, so at this point in time, it is an equitable solution. On the other hand, wind power and hybrid cars and things like that, they are bearable solutions. Okay, it's not yet economical at this point in time. And on the other hand, for instance, if you look at a bicycle mode of transport, okay, it appears that one can argue that it's a sustainable approach. While it is environmentally friendly and economically viable, it may not be socially appropriate in many contexts, especially in the Indian context. Okay? People still have a taboo about traveling in a bicycle. Okay? Then it could be a viable solution. Okay? On the other hand, we can also talk about a context of sustainability. For instance, gobar gas, okay, in certain situations can be considered as a sustainable solution, whereas in an urban context, it may not be a sustainable solution. Okay? Sustainable solutions from the point of view of civil engineering, there are quite a few examples. For the popular example is stabilized mud block. Okay? It's a sustainable approach. It's socially acceptable, environmentally friendly, and economically viable also. Okay? Blended cement is a sustainable solution. Rainwater harvesting is a sustainable solution. And so on and so forth. One can talk about, okay, what is sustainable or otherwise, okay, depending upon how one gives a weightage for these three important aspects. very interesting that NBC, of course, although it's got its 2016 edition, it came out recently, just about slightly more than a year back. Part 11 is completely dedicated to approach to sustainability. Okay, it gives a clear advice about issues pertaining to resource consumption. It talks about materials and energy, which I presume Professor Jagdish would have discussed extensively yesterday. Degradation of environment, eco-balance, climate change, global warming, and so on and so forth. It also talks about inequitable development. Okay? So, in a way, if you want to understand sustainability, we need to understand the life cycle perspective, and we have to understand that in a holistic manner. Okay, we have to look at all aspects and then decide whether it is really sustainable or not. Okay. So that's the background of NBC. I think it gives a very interesting context to engineers, especially civil engineers. Okay, and it has got several sections. Okay, right from what you are going to do while the site is developed. Okay, and then structures and infrastructure is designed and erected over there. It talks about optimization. It talks about materials. It talks about minimizing the waste. Okay. It talks about practices, construction practices and technologies. It talks about how to track whether something is working properly or not, and so on and so forth. In many ways, it encompasses most of the current rating systems. Okay, in my opinion. Okay, I urge the participants to have a look at NBC 2016 Part 11. Okay, to enable understand this workshop in a better manner. With that brief thoughts about sustainability, I will move to the main part of structural masonry. I will try to make a case why structural masonry can be considered as a sustainable approach. By the way, a small break here. I presume I am audible. Mr.
Yes,
Girish?
sir. Yes, sir. Yes, sir. Very much, sir.
Thank
you.
Can be understood very easily by comparing it with one of the most ubiquitously used construction materials, namely concrete these days. Okay, concrete is such a popular material that I'm going to use concrete as a material to compare masonry. In many ways, both are similar. Both of them have got bigger sized aggregates and smaller sized aggregates and binding material. Okay. In case of masonry, the bigger sized aggregates or the masonry units are of uniform size and shape. Okay. Whereas in concrete, the coarse aggregates are not of uniform size and shape. They are irregular in nature. Okay. And of course, to fill the voids, okay, and to increase the density, there is fine aggregate, and they are all bound together with the very popular binding material, namely cement. In case of masonry, the masonry units are joined together with the help of mortar, which consists of fine aggregates and the binding material. So, in many ways, from the point of view of disposition of the size of the materials, both of them are same. But the important difference comes in the way the coarse aggregates are dispersed. Okay, so the picture is self-explanatory. In case of masonry, the masonry units are geometrically well disposed. There are beautiful patterns of arranging the masonry units. There is this popular English bond, Flemish bond, Dutch bond, garden wall bond, okay, herringbone bond, diagonal bond, and so on and so forth. Okay. In case of concrete, you don't have such well-defined disposition. Okay, it's just mixing all the three ingredients together and then pouring it into a formwork. Okay. Now, this makes it, this is the point of departure between concrete and masonry. Okay, because the bigger sized aggregates in masonry are laid, okay, one by the side of the other and one above the other in a prescribed manner. You don't need formwork. So masonry enjoys the benefits of avoiding the usage of formwork, whereas concrete needs formwork. You need to pour concrete, whereas you need to construct masonry. So that's the one is an advantage and one is a disadvantage. Because you are pouring the concrete into a formwork, you can have reinforcement embedded into the formwork. Okay, so therefore the tensile strength of concrete can be easily achieved, okay, through the reinforcements which are embedded into that. Okay. So while concrete on its own does not have good tensile strength, the reinforcement in concrete makes it very popular reinforced concrete, okay, RCC as we know it. Okay. In terms of behavior, both of them are good in compression, weak in tension and flexure. Okay, both of them are brittle. Okay, of course, crack patterns in concrete is very irregular. Okay, and although the material is heterogeneous, it can be considered as isotropic. Whereas masonry cannot be considered as isotropic. It is an orthotropic material. So the properties perpendicular to the bed joints and parallel to the bed joints greatly differ. Okay. Generally, it is the interface between the masonry unit and the mortar, which is a weaker plane. And generally, cracks appear at that interface. Okay. So these are some of the differences. So as I mentioned earlier, because you are going to use formwork, you can have any complicated reinforcement arranged in concrete. Okay, so and you can pour concrete. Whereas in masonry, if you want to introduce reinforcement, it is quite involved. Okay, so the mason has to work a lot to ensure that the reinforcement is placed, okay, surrounding that masonry. Okay, so the masonry construction has to happen surrounding it, okay, in a complicated manner. So reinforcing masonry is not as easy as you reinforce concrete. Okay. Of course, for a civil engineer, concrete is a most popular material for a civil engineer because of its limitations in terms of strength and performance and so on. Or most of them are perceptions. Okay, it's considered as a frowning. Okay, it's the other way around for architects. Architects simply love masonry. It's no wonder that at one point in time, okay, all the 7 wonders of the world was made of masonry, okay, exposed masonry. To sum up, the advantage of masonry is the fact that you don't need formwork. Okay, it plays a dual role, functional as well as structural role. Okay, it is very economical. If it were not economical, it would not have been utilized. Okay, as a very popular construction technique from thousands of years. So certainly it's economical. It's also durable because you don't use materials which corrode. Okay, unreinforced masonry has been very popular, and you don't have any corrodable material in that. Okay? Therefore, it's durable. It is also aesthetic. Okay, so because of the disposition of the masonry units. Of course, these days masonry can be made ductile. Can be made ductile very easily. It can also be made lightweight. Earlier, people used to talk about brittleness of masonry as a disadvantage and the heaviness of masonry as a disadvantage. But these two now have moved into advantages of masonry. You can make a lightweight concrete, and you can also make ductile masonry. Lightweight masonry and ductile masonry. Of course, the disadvantages still persist. Okay, structurally it is very complex. Okay, most of the structural elements in masonry are two-dimensional in nature. For instance, if you look at a wall, it's a two-dimensional component. Okay, so it's structurally very complicated. Okay, so it's most of the elements in concrete, especially a framed concrete structure, they are one-dimensional, whether the beams or the columns. Okay, so it's very easy to analyze and understand one-dimensional elements. And there are far too many variables, different types of masonry units, different types of mortar, different ways in which they are laid. Okay, and no two locations practice the same type of masonry construction, and so on and so forth. And the presence or absence of openings in a masonry wall or the masonry structural components, they all make it very complex. Okay? There are too many variables. Okay? So that's the disadvantage of masonry. To make the things quite simple, okay, I have put these 3 bullet points. Okay, structural walls are the major structural elements of a building. Okay, they have got 3 roles to play. Okay, namely, one, it has to resist the vertical compression. Most of them are because of the gravity loads, the dead load and live load and things like that. It has to resist out of plane bending. Okay, in the event that there is a lateral load, if there is a masonry building subjected to lateral loads, the walls of the masonry building will be subjected to out of plane bending. Okay, that has to be resisted in the event that you are going to talk about multi-storied masonry buildings. It should also resist the in-plane shear. Again, when there are lateral loads, okay, such as earthquakes and things like that, you need to talk about resisting the in-plane forces. So from the point of view of structural mechanics, it has got three major roles to play, but resist vertical compression, out of plane bending, and in plane shear. These are the three important things. It is possible to achieve all the three things without even having the need for reinforcement to a large extent for most of the low-rise masonry buildings. It is possible. Okay, I'm going to discuss about that also. A quick background of how masonry walls are designed. Okay, a schematic diagram. You can see the load from the floor or the slab or the roof. Okay, is going to be distributed on the wall. Okay, so you need to find out the load acting on the wall, find out the stresses, and compare it with the or correlate it with the strength or the capacity of the wall. Okay. Ideally, or not ideally, okay, just like in most of the civil engineering materials, see, this happens even in concrete. Okay, while the masonry units may be good, the strength of masonry itself could be very low. Okay, so for example, if the block strength is 40 megapascals, and if you are using one of the best type of mortars described in IS 1905, whose strength could go up to 8 megapascal, the masonry strength which is mobilized is only about 3 megapascals. Sorry. This happens even in concrete. You can have a very strong aggregate, okay, and you can have a very good cement, okay, but the interface could be very weak. Okay, so you might have an aggregate whose strength is about 300, 400 megapascal, and you might end up with a 20 megapascal concrete. So the same thing happens in masonry also. So this has to be taken into consideration. It is not the strength of masonry unit alone which dictates the strength of masonry. Okay, it's the complex interaction between the mortar and the masonry unit which plays a role in resisting the forces. Just like you test cubes and cylinders in concrete, you are going to test masonry prisms. Okay, it's a representative sample of the masonry units and mortar which is going to be used in the building. You are going to assemble the units one above the other, okay, and then construct a small prism, okay, and then test it. Okay, so the compressive strength of this is going to give the masonry prism strength, okay, or the masonry strength, and that is the one which has to be used for finding out the capacity of the wall. Okay, of course, as the wall becomes taller, the capacity reduces, and as the loads become eccentric, again the capacity reduces. Okay, this also has to be taken into consideration. Okay, so the geometrical aspects and the material aspects both are taken into account. You are going to come out with the slenderness ratios and stress reduction factors, and then design this. But more important than all these things is the fact that, okay, you need to configure masonry in such a manner that it remains stable for all possible load combinations. Okay, that is more important. If you look at most of the codes on masonry, whether it's the Indian codes or the other codes, okay, it talks about the first step in masonry design is to get the configuration right. You need to get a robust configuration. In fact, our Indian code talks about a box type construction. Okay, if you have got a room with 4 walls, okay, that is supposed to be, or that is generally it's not supposed to be. Okay, it's a very robust configuration. Okay, it talks about configuration, getting the configuration right. Okay, and then check out for the capacity. Okay, you configure it properly. Okay, and then check for the capacity. Okay, it's a in many ways it's a stability based design. Whereas concrete and steel, they are strength based design. You check for the strength and check out for the limit states of performance like deflection and so on and so on. In masonry, it is stability based design. You get the configuration right and then check for the capacity. So getting the configuration right plays a very, very important role in masonry. This is something which one has to understand before we discuss something about masonry design. Summary of the 3 roles masonry wall has to play: resist vertical load, resist in plane shear, and out of plane bending. All of them are shown pictorially. I've taken it from IS, the masonry code itself. Okay, so okay, again a quick comparison between load bearing masonry and then moment resisting RCC framed building. In RCC framed building, much of the vertical load is taken by discrete elements known as columns. In load bearing masonry, the walls are the ones which are going to bear the vertical loads, the gravity loads. Okay. So you can very easily discern that the stresses acting on masonry walls are quite small because of the larger footprint we get. Okay. That's a benefit which masonry enjoys. Okay, you don't need to have M20, M30, M50 grade of concrete. Okay, you can construct 5 to 6 story masonry buildings using M10 grade masonry itself. Okay, it is possible because the stresses are really very low. Okay, because you have got a large footprint at the base of the building. Okay, so that's the difference between load bearing system and a framed system. Okay. Oh, sorry, this is a repeat of what I had already mentioned. Now, to summarize the brief introduction to the structural mechanics behind masonry, especially unreinforced masonry. In case of unreinforced masonry structures, the lateral stability is provided by gravity. Okay, so thicker walls and well configured walls, okay, and well disposed walls. Okay, they are the ones which are going to provide the lateral stability. No part of unreinforced masonry is allowed to develop tension. Okay, it is a compression dominant topology. Okay, no part of masonry is allowed to develop tension. Okay, because tensile strength is quite negligible. You don't want any part of masonry to develop tension. Okay, so these are the two important things. Okay. So hence, unreinforced masonry structures have to have sufficiently large base width so that the resultant of all the forces typically passes through the middle third. Okay, it does not cause any tensile stresses. Okay, in any of the wall elements. Okay. Now, very interestingly, adhering to these two cardinal requirements, there have been fantastic masonry structures which have been constructed. Okay. I will take you to those examples and then move on further to the third part of my lecture. Okay. So to sum up, masonry is a compression dominant topology. Okay, there's one example where you can simply arrange the masonry units, okay, to ensure that the forces are compressive in nature and then the stability is achieved by the proper geometric configuration. Okay. I will move to the third part of my my lecture. Okay, I'm going to discuss quite a few examples of how masonry has been configured to take care of only these two things. Okay, so the lateral stability provided by gravity, and no part of masonry is subjected to tension. Okay, and you can notice that okay, these two were never a limitation to the ingenuity and innovativeness of the engineers. Okay. Here is one of my favorite examples. There is a very popular building in Thanjavur. Of course, Thanjavur is well known for the famous temple, Brihadeshwara temple. Right near to that temple, there is this opposite to the Saraswati Mahal library. There is this tower. Okay. It's a multi-storied masonry building. It's actually a 9-storied tower. Okay. Although you can see only 8 stories here, there is one more below in the bottom of this picture. It's a watchtower. It is constructed nearly 250 years back, 2.5 centuries ago. It's completely constructed using brick and lime mortar, no reinforcement at any location, and so well configured that you don't have any distresses noticed in this structure. Okay? It's a tall structure. Okay, so it has withstood all the environmental effects over the past 250 years. Absolutely no distress at all. Okay? Of course, on the left hand side, you see my picture. So that is there. I will move on to other few examples. The one on the left hand side is, of course, there are innumerable monuments in the city of Gulbarga and then Bijapur. Okay. Many monuments are there, masonry buildings and structures. Okay. So one of the large archways, okay, into one of the complexes, you can notice the height of the masonry structure and then the span. Because it was so large, I had to come quite a farther distance away to take this picture. And you see one of my friend who is nearing about 6 foot, okay, standing next to that, and you can discern the height and thickness of the wall. Okay. So it's so neatly configured, okay, that the entire structure is dominantly in compression. Okay, so stability is achieved by the massive thickness at the base. Okay, the one on the right hand side is the famous Roman viaduct. Okay, I've taken it from the internet. This is yet another beautiful example of how masonry can be configured to achieve only two things. Okay, no tension developed in any part of the masonry. Okay, and robust configuration. Okay, so the resultant passes through the middle third. Okay, nowhere tension is developed, and it's such a beautiful configuration. The dome is there, okay, dominantly under compression. There are quite a few minarets, very slender, but so precisely constructed that the resultant passes through the middle third. And very thick base. Okay, so it's a famous Ibrahim Rauza temple in Bijapur. Okay, so it's a very inspiring and an iconic masonry building. Okay, constructed way back several centuries ago. Hardly, of course, there's no cement used. It's basalt stone in lime mortar. There's hardly any distress which you can notice in this. Of course, quite a few of the architectural components of this were inspired by nature. Okay, so people were able to exploit the potential of masonry to the maximum possible extent. Okay, so it's not surprising that you see so many architectural embellishments in this structure. Okay. So I will proceed to a few more examples. Sorry about that. Okay. And a few more examples that compression dominant configuration can be achieved by arches. Okay. This is a Barakaman unfinished structure. This is in Chitradurga, the famous fort in Chitradurga. Very thin mortar, or virtually it's actually a composite masonry. The outer surface is made of stone, and inner surface is made of brick or mud mortar and mud masonry. One of the another examples of the entrance to that fort, and you can see that there is an opening, there is a beam. Okay, and it has been made compression dominant by using a corbelling technique. There is no bending developed. Okay. So that's how masonry has been configured. This is one of the entrances to the famous fort in Bidar. Okay. Again, very complex usage of arches, the Persian arches, to ensure that it is subjected to compression alone. This is the madrasa in Bidar. It's the minaret is actually about nearing about 8 stories in height, and it's very surprising that at the top the diameter is only about 1.2 meters. Of course, at the base it's nearing 2 meters. As you go towards the top, it is 1.2 meters. Hardly 2 people can stand, and the entire structure is made of unreinforced masonry. Even to this day, it is withstanding all these effects of the external forces. And that is a complex next to it, 3-storied masonry building. There are quite a few examples in Bidar, the Astor Mahal complex, large domes. You can see the thickness of the dome in one of the collapsed structure. Okay, you can see that they have used a rubble stone in between the well disposed outer and inner bites of stone masonry. This is sort of the interlocking blocks, the Sandur temple, okay, the Kumaraswamy temple in Sandur. They have used interlocking blocks at the plinth level, and then above that also they have arranged these blocks, okay, in a very intricate manner. I used to think that there is only one example of this, but I have seen more than one examples of more than one in many parts of Karnataka. This is another example of how masonry can be made a compression dominant topology. This is one of the domes of a building, Jayalakshmi Vilas Mansion Palace in Mysore. The dome itself is very interesting. If you notice carefully, the polygonal dome has got 3 openings. Okay, one rectangular longer opening and the wider, and then a circular opening almost at the tip of the dome. Okay, so it's a sort of a ribbed structure. If you take a vertical section, it is hemispherical, and if you take a horizontal section, it is octagonal. Okay, so it's a polygonal dome and compression dominant topology. Okay. the exploitation of the architectural beauty and structural intricacies, okay, compression dominant topology was not restricted to buildings alone. It has also been used in, this is the famous Vanivilla Sagar Dam. Okay. So you can see the beauty of this dam. It's been constructed in using stone in lime surki mortar, in fact stone in lime surki, and hardly any problem is there. There is no problem of water leakage or anything. So its performance is one of the highlights of this. Okay. So what I'm now trying to tell is that, okay, it can play multiple roles of even performance against ingress of water. Maybe a couple of more examples. This is one of the heritage buildings in Bangalore. Although it's a single-storied building, you can see the disposition of this, okay, adding to the beauty of this, okay, and you can also see that the lateral forces, okay, are taken up by the provision of these buttresses, neatly configured buttresses. Buttresses are considered as ugly appendages to structure, but in this particular case, it has added to the beauty of the structure. This is the All Saints building. I had an opportunity to work on the or understand this building along with my students. This is one of the load-bearing masonry structures, one of the first load-bearing masonry structures, multi-storied load-bearing masonry structures. I borrowed this picture from my professor. The 9-storied hotel building in Nashik. Ganesh Kamath was one of the first to use engineered hollow concrete block to construct multi-storied building. Okay. There are no columns and then beams. It's a load-bearing system. Few examples from other countries. Okay, this is the famous Monadnock World Heritage Building, okay, in Chicago. It was constructed way back in 1891. Of course, at that point in time, people did not have adequate knowledge on stability-based design and configuring the masonry walls for adequate stability. So they used to construct it with thick walls at the base. Okay, so the wall thickness at the base is almost 1.82 meters, more than 6 foot. It's a 16-storied building, multi-storied building. One of the first multi-storied buildings, much before RCC came into picture. As soon as this was done, there are a lot of efforts to understand and exploit the advantage of masonry. And University of Edinburgh has been doing a lot of work. And this is something which I have borrowed from the book by P.P. Sinha. There is a very interesting experiment of a 5-storied masonry building which is constructed using 100 mm wall thickness, and all the floors were loaded to its complete capacity. And after loading all the floors, one of the wall was removed in the basement or in the ground floor. Okay, despite that, the entire building remained stable. So this gave a lot of confidence on stability-based design. To put it in a very simplistic manner, if there are 4 walls in a masonry building contributing to a boss type construction, you need to analyze and design it in such a manner that even when 2 opposite walls are removed, the structure should be in equilibrium condition, stable equilibrium condition. That's how it is designed. Okay, so if there are 4 walls, 4 rectangular walls contributing to a rectangular form, okay, and the plan, even when you remove 2 opposite walls, the loads are taken up by the other 2 remaining parallel walls. Okay, that's how you need to configure. Okay, so this concept was understood very quickly, and then Europeans started constructing multi-storied buildings. Quickly, they came out with 16-storied masonry building and using only 200 mm wall thickness. Again, it went back to USA. They constructed the 18-storied masonry building using 200, and eventually at the top it was only 150 mm thick. Okay, so this was in Cleveland. Okay, so people quickly understood the concept of stability. Okay, so they were able to understand that you can achieve stability by getting a proper form. Okay, so one of the forms which I have been mentioning quite a few times is the box type configuration. You can also have hybrid configurations. Okay, so tubular configurations and so on and so forth. Okay, by that time, people had comprehensively understood the masonry. Okay, and then it was exploited even further. Quite a few architects exploited masonry to the maximum possible extent. They are all structures of beauty. Okay. The church designed by Eladio DSATM is an example that you can achieve stable configuration not necessarily by straight vertical walls. Here is a very interesting example of the walls of this church building. In the plan, it is sinusoidal in nature, and in the section, it is parabolic, hyperbolic parabola. That's the beauty of this masonry building. Okay. So you can achieve stable configuration um, by any geometrical patterns. Okay, so it is possible. Okay, and most of them they work on the concept of intuition and then checking out with models and things like that. This is one of the beautiful examples of a stable configuration, not necessarily using vertical walls. This is an inner view of that. Okay, so you can see the beauty of masonry. Okay, so the exposed masonry. The roof was also very interesting. It's reinforced masonry. I will come to that very soon. Okay, so this is another example. Okay, hyperbolic paraboloid on the the walls, and this the other example. Okay, it's a thin shell protruding shells. Okay, to take care of the configuration on the lateral forces. And much before Eladio DSATM started exploiting masonry to the maximum possible extent, much before him, I cannot miss any lecture on masonry without quoting Antonio Gowdy, one of the famous architects, okay, and who was inspired by nature, okay, and then constructed fantastic masonry buildings. Okay, these are all masonry elements. They all look like almost the bones of living animals, okay, or human beings. He configured the walls and then the columns and things like that, okay, inspired by nature. And again, it was a compression dominant topology. No part of the structure was subjected to tension by sheer configuration. Okay, this is an example of that. A few more examples. How he achieved the compression dominant topology is very interesting. Of course, one of the famous churches which he constructed, okay, is this one, in Barcelona, and how he achieved this was very interesting. You know that when you take a tension member, a catenary, okay, and support it at two ends, okay, if you take a chain and support it at two ends, it will be subjected to pure tension, okay, and inverse of that, when you flip it, okay, then it has to be pure compression. So what he did was the same thing. Okay, he got the form by suspending several small weights, okay, into a form he wanted, okay, and from the ceiling, and he projected the section he got on the vertical walls, okay, and then inverted and then got the compression dominant topology. It's a fantastic example of how you can achieve exploit masonry to its complete potential. Okay, so people were not limited by the disadvantage of masonry. Okay, of course, the disadvantage of masonry is that it cannot take tension. Okay, but that thing was completely avoided. Okay, no part of the structure is developing tension. Okay, this is one of the pictures of that. Okay, few more examples. Okay, and it's not that it was only limited to such buildings. Even the pillars and then roofing elements, you can see the ribbed structure over there. Okay. Compression dominant topology, completely exploited to its potential. Okay. You can see a whole variety of masonry here. Roofing elements, the columns and the exposed masonry, almost like using rubble masonry, okay, composite masonry. Okay. So a few more examples. I would like to summarize by telling that, okay, these limitations of masonry, structural limitations of masonry, did not. I mean, people were not deterred by the limitations. Okay? There are fantastic architects and engineers who exploited masonry to its complete potential. it has been exploited to its complete potential. Even in India, there have been quite a few examples which I showed earlier. Okay. Of course, the advent of reinforcement and reinforced masonry made it even more fascinating. Okay. So the advantage of using reinforced masonry is that you will get multiple benefits. It can become ductile. You can prevent the brittle board of collapse. Okay. You can design it to withstand lateral forces very easily. Okay. And these are all few examples. Now in Western countries, people talk about pre-stressed masonry also. Okay. So we are yet to come there. Okay, we are just making small beginnings in reinforced masonry. I just wanted to share this picture, reinforced masonry. Okay, so I'll quickly move on to masonry construction practices in developed countries. Okay, especially from the point of view of how it is made sustainable. Okay, so this is how masonry is constructed in the current context. They have long back done away with solid blocks. They know that solid blocks are no longer efficient, so they use engineered hollow concrete blocks, engineered to its complete extent in terms of strength, performance, okay, the size, and then the shape. Okay, you can get any strength, any size, any shape, any texture, any color. Okay, it's engineered to the maximum possible extent. Okay, so these are all the engineered blocks. Okay, you can see the beige colored blocks being used. So, and this is how it is constructed. And the mortar is also engineered. They use lime dominant mortar, ease of workability, and very compatible with the blocks. And the way they do this is so very sustainable. You hardly need, you hardly end up with any wastages. Okay, you don't need plastering. That's one of the biggest advantages of exposed masonry. Okay, so the cost comes down, use of material comes down. And you can notice a small detail, okay, of covering the wet process by a plastic sheet, okay, prevents the spillage of mortar onto the exposed masonry. So you don't need any repetition of cleaning and things like that. Okay. So neatly configured, well-defined set of operations. Okay. So this is how they do it in the Western countries, be it in the European countries or New Zealand or Australia or America. Okay. In fact, even Brazil has got fantastic examples of such construction techniques which are adopted. Okay. I will come to the fourth part of my lecture. Okay. In a way, this is also the main contribution to this lecture, in the sense that how masonry can be considered as a sustainable construction. Okay. Is it socially acceptable? Is it economically viable, and is it environmentally friendly? Okay, we will discuss about these things again through examples. I'm going to discuss something about the sustainable approach, masonry construction approach, through case studies. I'm going to take up all the three scenarios in the rural context, and the semi-urban context, and the urban context. Okay, so okay, I'm going to talk about my own experience while I have been engaged with this architectural NGO by name Nivasa. We are working towards enabling humane housing solutions for very poor people. This is a village in Kanchipuram district. Actually, it's quite close to Chennai, the city of Chennai. It's about 65 kilometers away from Chennai. There are some tribals living in such type of tenements. It's just about 4 feet high wall. Okay. Of course, it has got a very comfortable thatched roof, thermally very comfortable. 4 feet high wall. It has got 4 walls made of mud. Okay, rudimentary construction. But they are living in very inhumane construction. Okay, they don't have toilets. They don't have separations inside the building. Okay. During the heavy rains, okay, much of these people they suffered a lot. So we were asked to engage with them to come out with solutions for that. Okay. So we had to educate them of how to construct masonry, and of course, cost was a major constraint. Okay, using locally available material was another major constraint. Okay, and then the fact that they had to do it themselves to avoid construction cost was also another major constraint. So we trained them on how to make adobes, okay, stabilized adobe. Okay. Professor Jagdish and his team Dr. Yogananda and Professor Venkatram Reddy, they have all contributed a lot to stabilize mud block. And stabilized adobe was also, it came out well with one of the interesting modes designed by Yogananda and his team, the 5-sided mode. So we trained these people to make their own blocks. Okay? The locally available soil was engineered, or you can call it as processed. Okay, so the unwanted material was removed. Okay, only this dominantly sand was used. Okay, little bit of silt and little bit of clay, and you add a required amount of cement only to the extent that you need strength for the G+2 in the event they want one more floor to be added. You mix it thoroughly, okay, and then compact it, hand compact it, okay, pug it properly, hand compact it, eject it. Okay, you don't need machines, you don't need power. You just eject it, stack it, cure it, and then start using it. Okay, so this turned out to be a community process. All the people started doing this whenever they had free time. So they started doing these bricks. At some point in time, they had sufficient brick to construct their house. They started constructing it. Of course, it's an engineered brick. It needs the due diligence of correct proportioning, correct casting, and then weighing and casting, and then compacting, curing, stacking, everything. Okay, so all these were training was imparted to the villages. Okay, and then they came out with this type of housing. Okay, so they were able to get a robust house, okay, at a very low cost. The point which I'm now trying to tell is, okay, this is a sustainable approach to one of the housing problems. Okay, initially about 6 houses were constructed using this. Now there are about 15 people who want to construct, 15 families who want to construct houses like this, and gradually people from other village also want to emulate this. Okay, so this is a very sustainable approach. Okay? So they got a very good house, okay, as they had aspired for. Okay, so with this type of technology, okay, socially acceptable, environmentally friendly, in the sense that we have been using locally available materials. Of course, cement is the only one which is a bit expensive and then brought from elsewhere. That's a small price which you need to pay to get such a drastic change in the configuration of the house. Okay, so back in Karnataka, there are quite a few, not quite a few, innumerable poor families living in villages. Okay. I'm going to talk about one village in Chikbalapur district, the Udagiri Nalapanahalli. So there people, although they are economically well off, somehow they are not able to mobilize funds good enough to construct a pakka house, so to say. Okay. So they were residing in such rudimentary houses and some temporary arrangement, okay, of thatched roofing. Okay. And they replace these thatched roofing every season, after every season. Okay, and they continue to live there. So they had aspirations for constructing a pakka house. Okay. So they were also trained with this same stabilized mud block technology. All of them started participating. Okay. We also trained them on how to make their own roofing elements. Okay. So they were able to quickly assimilate this technology and come out with their beautiful houses for themselves. Okay. So here is the training process which is given to the villagers. Okay. And then, of course, stone is available in plenty in that region. They had used stone as a sill level band and the lintel level band. They also use stone for the roofing system also, the chapdikal, okay, stone slabs, stone panels there, they use it for the roofing system. Okay. The walls were made of stabilized adobe. This is a small hamlet near Anekal Taluk, just about 35 kilometers away from center of Bangalore. So they were also provided stabilized adobe. Okay. And it's not that stabilized adobe is a solution for all housing problems in rural context. In and around Western Ghats in Udupi, in Cherkadi, okay, there is this interlocking mud blocks available. So this is one of the houses. Of course, you need a slope roofing system there for the to take care of the rainfall. Okay. One example. Laterite blocks are locally available materials. Okay. These are all sustainable approaches to the local problems. Okay. I will move on to a semi-urban context. Okay, this is the school building campus in Chikbalapur, the Dwarkanath Reddy Ramanar parameters. in this village, about 15 kilometers away from Chikbalapur town, good quality bricks were not available, concrete blocks were not available, okay, and had they wanted to transport bricks and blocks from either Chikbalapur or Bangalore, okay, they had to end up with a heavy price for the transportation. Fortunately, good quality mud was available for making stabilized mud block, engineered mud blocks. So the architect suggested the use of mud blocks for this building. The architect is from Gujarat. So he suggested this, and then quite a few buildings in this campus was constructed using this stabilized mud block. You can also see stabilized mud block used as a filler material in the roofing system. Okay. Again, compression dominant topology, very less usage of RCC elements. So this is the interior of this building. Exposed masonry. The moment you talk about exposed masonry, straight away the first tenet of sustainability is achieved. Reduce, reuse, and recycle. You are going to reduce the usage of materials. Okay? The cost comes down. Okay. So this is the classroom and the tailoring room. The hostel complex in that building. Moving on to the urban context, okay, there have been innumerable number of innovations in hollow concrete blocks. Okay. Besser concrete products, Axon. Okay, now Soba developers have come out with their own product. Quite a few cement manufacturing companies have come out with engineered products. Okay. A variety of engineered blocks, lightweight, hollow, okay, textured, varying thicknesses, varying sizes, varying colors. So this is an example of villas constructed near Bangalore. Okay. And of course, to exploit the advantage of masonry, the lintel was also made of U blocks. Okay. You see my two good friends from my department, Professor Ranganath and Professor Suresh. Okay. So there is this U block, okay, which is used as a lintel. Again, you don't need formwork. You use the U block itself as a formwork. Place the reinforcement and pour self-compacting concrete and then finish off the construction. So these are the houses which are constructed. They got the multiple benefits of cost effectiveness. Okay, sustainability was, of course, was the main target. They ended up with a platinum rating for adopting this technology. It was one of their key points. So apart from the other things which they did in their project. Okay, so of course. There are other engineered masonry units. Very popular among them is almost like the terracotta products and the clay products. Okay. You've got clay roofing elements, wall elements, column elements, pillars, flooring elements. A variety of products are there. Vertically perforated blocks, horizontally perforated blocks. The vertically perforated blocks also enables the insertion of reinforcement. Should you want to go for reinforced masonry, you can also do that. So these are all available in almost all parts of India. Okay. So this is yet another example of an institutional building in Mysore, the Swami Vivekananda Youth Movement Campus in Mysore, okay, which was constructed using engineered hollow concrete block. You see the placement of the lintel blocks, okay, and you see the structure being dispensed with RCC, the conventional RCC elements. So wherever there is a requirement for a huge beam for the large span, instead of using a conventional RCC column, we suggested reinforced masonry column. Okay, so you see the reinforced masonry columns. Okay, it's a dominantly load-bearing system. The walls are also carrying the load, and of course the RCC reinforced masonry columns are also taking the load. So none of the elements here is redundant. In a framed system, the infill wall is structurally redundant. Okay. Whereas in case of a load-bearing system, okay, reinforced masonry, the walls are also structurally participating in carrying the load. Okay. So that way, it is going to ease out the stresses and distributes the load sort of equally on all the structural components. Okay. So this is the advantage of using reinforced masonry. Again, because the reinforcement has been introduced through the hollow portion, you don't really need formwork. Okay. It's an exposed masonry construction. Although it was designed for G+3 story, they have constructed only 2 stories now. It is exposed, by the way. It is just putty finished and painted. with that color. So looking at the advantage of this, quite a few people in Mysore started adopting this technology. Here is an example of a residential building in Mysore, a posh residential building. It's exposed masonry. Okay, so this is one of the locations in Mysore. Okay, so they have used engineered hollow concrete block. Yet another example of how to minimize the wastages in masonry construction by looking at the way masonry construction is practiced in Western countries. Well-defined set of operations, zero wastage or near zero wastage. Okay. Quite a few people in Mysore were enamored by that process, and they started practicing this. I'm going to give an example of one Mr. Nagendra, who happens to be an electronic engineer, who came out with a very innovative way by which he could achieve virtually zero wastage. Okay? So, so he had color configured the requirement of the appropriate blocks for the appropriate location. The full block, the half block, the lintel block, okay, the conduit block, okay, and looking at the availability. So he had given a color coding for his building, and then the correct block went to the correct location. Okay, and we had also designed a template to minimize the wastage of mortar. Okay? The mortar should not spill into the hollow portion. Taking out or scooping it out would become difficult. So a template was also designed. Okay, the wastages became very minimal. Okay, so this is yet another approach to sustainable construction. Virtually zero wastage and reduction in use of materials. Okay, and then of course, the benefits of that is economics, okay, cost effective, okay, and of course socially acceptable. So this entire building was constructed in quick time, okay, and neatly finished. Again, you can notice that it has not been plastered. Okay, the pointing was done in putty, and then the entire building was completed. Okay, another example of innovativeness in masonry is that use of stabilized mud block as dry interlocking units. So I'm sorry, this thing is hidden in this toolbar. Architect Rajesh Jain has been constructing quite a few buildings using the stabilized mud block, and the stabilized mud block are interlocking. Okay, so the dry stack interlocking is possible. This entire building, this entire process, I was able to see it. Okay, what you see in the picture was constructed within a matter of 20 minutes. Okay? It was just assembled, okay, and then constructed. So up to the lintel level, within a matter of an hour, okay, you can construct the entire process. Of course, you have to use the appropriate process for the wet part of it. Okay, so this is a close-up view of the interlocking blocks. Engineer Ashok is also trying to come out with a lot of processes for this, precision and things like that. Back in Bangalore, there are quite a few architects who have been exploiting stabilized mud block to its maximum potential. People often tend to think that the floor plans have to be identical for getting load-bearing masonry. It is not really needed. Okay, architect Prasanna has constructed quite a few houses, okay, of beautiful form. Okay, so the upper floor is projecting out, and you wherever needed you can have the RCC elements. The beam is projecting. Okay, and wherever needed you can strategically introduce the reinforcement, or you can go for RCC columns. So this is a very good example. If you carefully notice that there is use of stone pillars, okay, and cantilever RCC beams. So this is exploited to its maximum potential. Again, exposed masonry. Okay, so stabilized mud block has come a long way, okay, and is accepted in the urban context. You can also use it for roofing elements, okay, a combination of variety of alternative roofing solutions along with wall solutions. I gradually move on to the last part of my lecture. When we talk about sustainability in the modern context, people talk about energy, embodied energy, and things like that. Here is an example of an engineer in Mysore, Ramesh Kikeri, who constructed his house using all possible sustainable technologies. for all components, including water heating and the solar power generation and so on and so forth. And then, of course, the embodied energy of the entire building was as low as 1.05 gigajoule per meter square. Okay. So it's one of the lowest embodied energy which I have ever come across. Okay. I would like to come to the last part of my discussion. One of my colleague, Dr. Varsha, has done a lot of study of a variety of studied a variety of forms of buildings, multi-storied building, single family buildings, multi-family dwellings, monolithic buildings, RCC buildings, and so on and so forth. Okay. We found something which is very interesting. Masonry dominant construction, okay, not only are cost effective, but it was also quite low in terms of embodied energy. You see a whole option of possibilities in masonry, okay, where the embodied energy is also quite low and cost is also one of the byproducts of benefits which you get. In the process of reducing the cost, okay, you'll end up with reducing the embodied energy or vice versa. You want to reduce the embodied energy, you will also end up with reducing the cost. Okay, so there are a whole lot of options which one can exploit. Of course, it's not that masonry can be used for any type of construction. It has got its own limitations. For example, the multi-storied buildings in Bangalore, I don't think so masonry is a solution for that. Okay, in the urban context, it has got its limitations, especially when you want 2 or 3 basements and then 10 to 20 stories and 30 stories, story buildings and so on and so forth. It's got its own limitations. But for low-rise structures, okay, it's very interesting to note that masonry has got a solution. Okay. Low embodied energy, low cost, variety of options are available. Okay. These are all some of the buildings which are studied by my colleague, and we found out that okay, masonry is quite sustainable from the point of view of embodied energy also, okay, and not only from the point of view of cost. Lastly, I would like to come to the last part of my lecture. Of course, I have made some case that okay, masonry is sustainable in quite a few contexts, either in the rural context or in the urban context. Okay, where cost is a major constraint in one case, and where social acceptance is a major constraint in the other case. Okay, you can notice that masonry is acceptable. Okay, so it's cost effective, it's acceptable. Okay, and we also found that its embodied energy is low. Okay, it's also possible. Okay, in future to talk about using the masonry units to its complete potential. Okay, so it could also be sustainable in the long run. Okay, it's also possible to do that. Okay. On some personal thoughts. Okay, whenever we talk about sustainable approaches and design, sustainable design and construction, of course, the cardinal tenets are that we need to reduce, reuse, and recycle. We need to satisfy this. The first step is to reduce the usage of materials as much as possible. That's very, very important. And I've shown the example where by avoiding certain redundant materials, okay, or components like plastering and column and things like that, you can reduce the cost and you can reduce the usage of materials. You need to exploit local resources. This is something which is very important. If we want a sustainable society, okay, or a society which is going to grow in a sustainable manner, and the people have to be provided with the right kind of resources. Okay. You need to enhance the skill set. Local materials have to be exploited, local machinery, local human resources have to be exploited. We need to enhance all these things. Okay. Stabilized mud block is one fantastic example, okay, where it is contributing to the local economy. Avoiding capital intensive technologies is also advisable. Okay, of course, in a context, okay, you don't really need a heavy capital intensive technology for quite a few of our building stocks. For example, you want to construct about 10 to 20 houses in a village, you really don't need monolithic construction and RCC construction. It is possible. Okay. For instance, we see some very unsatisfactory examples of even single-storied buildings being constructed using monolithic construction, concrete construction. It's really disproportionate. Okay, So it's really not necessary. Okay, so you have taken all the advantages away from the end user. Okay, it cannot be broken easily. It cannot be reused. Nothing can happen. It's a box, concrete box. Okay, so it is not a good approach. Okay, there are a lot of masonry solutions available for this. That's the point which I'm trying to make. Okay. You need to develop and promote technologies that generate employment, sustain employment, upgrade the skills, encourage participation from wide skill sets, and open up new skill sets. Okay, you need to encourage masons to come, and you need to come out with technologies which is going to ease the masonry construction. That's very important. Okay, in my opinion, while in the other processes there are a lot of gadgets and tools. You want to help the carpenter, there are a lot of gadgets. You want to help the electrician, you have got a lot of gadgets. Unfortunately, it's still not there for masons. Okay, we need to come out with such things. That's very important. And if masonry has to go to the next level, we need to work like what is being done in the other countries. We need to have a lot of gadgets and tools and training programs for the masons. Lastly, I'll leave it at this slide. We need to reduce, reuse, and recycle. And sometimes we may have to refuse certain technologies which may not be really worth it, okay, or it could be inappropriate. Okay. With that, I conclude my lecture. Okay, I'm open for discussions. Okay, thank you.
Thank you, sir. Thank you for your presentation. Participants, sir is ready for questions. If participants have any questions, you can just comment it in chat box, and I'll read it out for sir.
Yeah. There are any questions? I'm willing to take. Okay.
Yes.
Or I have shared my email and then phone number. Okay. One can contact me through email. If there are any questions.
Sir, I will have a question. Could you throw some light on different reinforcing materials for the masonry? What type of materials could be cut?
Okay. Yeah. Okay. Different types of masonry materials. Broadly, there are two different types of masonry reinforcing elements in masonry. The ferrous or the metallic reinforcement, and the non-ferrous or the non-metallic reinforcement. Of course, when I say metallic, most of them are ferrous compounds. Okay, steel and so on and so forth. Okay. So the non-metallics, timber is considered as a reinforcing material. Okay, when if I can get an opportunity to discuss on earthquake resistant masonry, I can share some fantastic examples of how timber and bamboo have been used to withstand the lateral loads. Okay, the tension developed by timber and bamboo and things like that. It has been a traditional reinforcing material. Okay. Conventionally, the popular reinforcing material is steel. Steel is very convenient to be introduced in hollow concrete blocks. Very easy to introduce. Okay, our IS code now, masonry code talks about. For the first time, I just wanted to share this. Okay, for the first time 2 years back, reinforced masonry has come out. Okay, it talks about a variety of processes by which reinforcement can be introduced and how to design the masonry walls when reinforcement is there. Okay, there are a lot of approaches given. The analysis and design approaches. Okay. So, of course, I did not delve on reinforced masonry to the extent because it's quite involving. I need to give an introduction to the process behind it and then the mechanics behind it. I just skirted that aspect here. So there are a lot of approaches there also. And reinforcement, if you want to provide reinforcement only to withstand earthquake forces, there is a technique. And if you want to provide reinforcement to enhance the vertical load carrying capacity, there are other techniques. Okay, so it is possible. The examples of the building in Mysore, which I showed. Okay, I'll just go back to that. Okay, it's the reinforcement is introduced to enhance the load carrying capacity. So it's a reinforced masonry column. It's not a reinforced concrete column. So the hollow portion is grouted with compatible grout, compatible with the neighboring masonry.
Thank you, sir. Sir, we have one more question from Dr. Jyoti. I want to understand how tensile forces were addressed in many prehistoric monuments which you have discussed in your presentations.
Okay.
Right, ma'am.
Yeah. Good morning. Sorry.
Yes, sir. Yes, sir. I think that there was a
Yeah.
miscommunication. Yeah. Yes, sir. You
Yeah.
can go.
Good morning, Jyoti. I presume it is Dr. Jyoti from Ramnagar College. Okay. In fact, tensile forces were not handled, it completely avoided. What I talked about the topology of configuration in the examples is that they had configured the geometry in such a manner that hardly any tension developed anywhere. Okay. For instance, all these places, okay, tension did not develop at all. Okay, the domes and the walls, okay, and the massive wall thicknesses, okay, nowhere tension was developed. Okay, of course, the roofing element which you see here, there's reinforced masonry. Otherwise, there's no need of tension reinforcement at all. Okay, so back in India, there are innumerable number of examples. Okay, for example, Taj Mahal is a fantastic example of masonry, no reinforcement anywhere. Okay, standing examples of how you can configure and then construct masonry in such a manner that there is no tension developed anywhere. Okay? Taj Mahal is a fantastic example. There are innumerable number of temples and then other monuments. Okay? No tension developed anywhere. The Vani Vilasagar Dam, which I showed earlier, okay, of course, it's a gravity structure. The base which is so large that the resultant passes through the middle third. No tension developed anywhere. Okay? So people did not encounter tension at all in their configuration, or rather, they had used their ingenuity in such a manner that they dispensed with the tension. That was the beauty of this earlier construction.
Thank you, sir. We have one more question from Girish. Sir wants to know what is the maximum span that we can achieve from a masonry structure, and if there are any restrictions for that. I presume. Yes, sir.
Okay. As I said here, in my one of my slides, okay, the span depends. Okay, of course, I'll let me go the other way around. Okay, in case you need to design masonry walls, the loads have to be computed. The load acting on the wall. Obviously, larger the span, larger is the load. Okay, larger is the load, larger is the higher is the stress. Okay, and you need to go for better masonry. Okay, for example, table molded brick is much better than country bricks. Okay, wire cut bricks are much better than table molded bricks. Okay, engineered blocks are much better than wire cut bricks. Okay, you can engineer to any strength and then okay. In terms of the maximum span, it depends on what basic ingredients you are provided with to withstand that. Okay, so if you have been provided a 5 megapascal Pascal block, okay, you can't exceed that 5 megapascals. So probably you are going to end up with larger thickness. Okay. So that's true in any engineering, civil engineering approach. If you are limited by the capacity, you are going to play around with the geometry. Okay. And the only geometry which we can think of immediately is to reduce the stresses, is to increase the thickness. Okay. So if you want to have the large span and withstand that using a low strength block, you need to increase the thickness. So I really cannot answer that question as a thumb rule or some kind of a number. Okay, you just need to design it. Okay, so span really is not a criteria, and these days with engineered blocks, you can go for large spans. I myself was fortunate to be involved with constructing a huge auditorium in one of the building which I showed in Chikballapur. The spans were about 6 meters. Okay, so and the wall thickness was 230 mm. Okay, so with 6 meter large spans, okay, for a classroom building. So we were able to construct the walls using 230 mm stabilized notebook.
Thank you. Thank you, sir. I believe we have time for one last question, sir.
Well,
Yeah, sir. Professor Sridevi, she wants to know that she has found some horizontal cracks which are formed below the slab, usually in the masonry buildings. Ma'am wanted to know how we could prevent such cracks.
Okay. Cracks in buildings occur for so many reasons. Okay. Innumerable number of reasons. I really will not be able to comment straight away. Typically, yes. Okay, I tend to make a wild guess that load-bearing masonry, when it is supporting an RCC slab, when the RCC slab deflects, okay, at the end, okay, because of the deflection, okay, so there will be a rotation at the end of the slab, which is supported on the wall, and that leads to a horizontal crack on the outer face of the wall. So this is a common problem which I have seen in many places. Okay? Not only in Bangalore, but many places. Okay? It has got more to do with the deflection of the slabs, okay? Which that rotation which masonry cannot withstand. Okay? And these days we are using non-flexible mortars. Earlier we used to use mud mortar and lime mortar. It could take certain amount of subtle deflections and rotations. Okay, these days we are using the cement mortar. Okay, it's very brittle and very stiff. Okay, a little bit of deflection of the slab leads to horizontal crack. That could be one of the reasons. Okay, but without having a look at the crack pattern or the structure, I will not be able to comment much on that. Of course, horizontal cracks do appear in a framed system also. Okay, that is because of the incompatible. The infill is incompatible with the surrounding masonry. I'm sorry, RCC columns and beams. Okay, so in the event that there is even a slight lateral load, okay, there will be a vertical separation and a horizontal separation. So cracks are quite common in most of the buildings. Okay, especially in masonry buildings. I presume that could be the reason. Okay, I'm just making a wild guess. That's it.
Thank you so much, sir. Thank you for the presentation. It was really an eye opener for most of us. I believe all of us. We have had a lot of insights into the masonry structures, especially in our presentation, also the presentations which we have heard the past few days, past few sessions. I think we have a lot of takeaways. Presentation was excellent to say the least. Elaborated on various examples, and we've a lot to gain from this session, sir. I request Dr. Subbalakshmi to kindly conclude on the session.
Thank you so much, sir, for your presentation and accepting our invitation for this speaker. I request all the participants to log in for the next session at 11:30. Thank you so much for the presentation, sir. Raghunath, sir.
Thank you.
Raghunath sir, you took us from the sustainability concept. You gave us a definition, and then with that background, you took the masonry, and then you very well defended. Rather, the real facts is how masonry is functionally good, and then structurally it is viable, economically it is feasible, and then also it is durable. And later on, after having the theoretical concept, you gave us a number of examples with the photographs, and you explained each one of them how it has been designed and how it is sustainable. And you also showed one or two buildings which are zero waste and zero tolerant buildings. And then you took us through the advantages of masonry structures as one of the sustainable concepts for any buildings. So it was real good, and this is what we expected from you. Of course, you are a very good teacher, and all of us know that. And sir, the session was very nice, and it was very apt for the topic that we had selected. We are very thankful for you sharing your knowledge and sparing your time with us. Thank you so much, sir, on behalf of management. Yes,
I'm humbled by, I'm floored by your nice comments. Okay, I'm not sure whether I deserve so much of adjectives.
It's a fact, sir. It's a fact. We have seen how you are, and we have also learned quite a bit from you. Though you're not directly teacher, we take you as our teacher.
Yeah,
so thank you, sir.
Okay. Yeah, thank you. And I'm sorry, I sort of hurried through my presentation. Okay. I know it's very uncomfortable for this online sessions. We are a bit of old timers. Okay. I hope in the coming future I'll be able to discuss in person. Okay.
Definitely,
and
sir.
also personally, I would like to meet you. Okay, it's been a long time, really.
Sure, sir. Definitely, sir. We would like to have you on board here personally on a physical one-to-one, and we'll have a good session for our students and faculty.
Yeah. So I'll send this the PowerPoint presentation to Madam Subalakshmi, and she can in turn share it with the participants.
Yes, sir. Definitely, sir. We'll do. We are doing it. Yesterday, Jagdish sir, he gave a bit of notes, and we have shared it to the students already.
Yeah. Thank you.
So thank you, sir.
Can I log out?
Yes, sir. Yes, sir. So good day to you, sir. Good day. Take care.
Thank you.
Over to Girish. Professor Girish.
Thank you, sir. Dear participants, I have a small poll running. Of course, it is regarding, it's related to the session that just concluded. Please give your opinions, and that would be marked, recorded as your attendance for the session. And we can come back at 11:30 a.m. Same link. Thank you.
MBA ಅವಾಗ ಒಂದೇ ಶುರು ಮಾಡಿದ್ದು
ಯಾವುದಕ್ಕೆ ಇದಕ್ಕಲ್ಲ MBA 1ಗೆ ನಾನು ಇವರು ನ್ಯಾಕಲ್ಲಿ ನ್ಯಾಕ್ 1 ಇವ್ರಿದ್ರು ಇಲ್ಲ ಫ್ರೆಂಡ್ ವಿನಾಯಕ್
ಜೊತೆ
ಸೊ ಮೇಡಮ್ ಸನ ಮೇಡಮ್ ಫೋನ್ ಮಾಡಿದ್ರಾ? ಹಾ, ಕೊಡ್ತೀನಿ ಅಂದ್ರೆ ಅದು
ಲಾಸ್ಟ್ ವೀಕ್ ಅಲ್ಲಿ ಒಂದು ಮೀಟಿಂಗ್ ಆಗುತ್ತೆ. ನಿಮ್ಗೆ ಯಾರ್ಯಾರಿಗೆ ನಿಮ್ಮ ಡಿಪಾರ್ಟ್ಮೆಂಟ್ ಅಲ್ಲಿ ಏನ್ ಮೇಂಟೈನ್ ಮಾಡಿಲ್ಲ ಅನ್ಸುತ್ತೆ ಅದೆಲ್ಲ ತಗೊಂಡು ಹೋಗಿ ಸಾಫ್ಟ್ ಕಾಪಿ ಡಾಕ್ಯುಮೆಂಟ್ಸ್ ಅಂತ ನಿಮ್ಗೆ ಯಾವ್ದಾದ್ರು ಬೇಕೋ ಫಟ್ಫಟ್ ಅಂತ ಕೇಳ್ಬಿಟ್ಟು ಇಸ್ಕೊಂಡು